Hi everyone, Miss P here. I wanted to give you a quick science lesson today, and I'm in my piano room because we are going to, as you know, we're working with sound, and today we're going to be learning about pitch. So my piano here will help us learn a little bit more about pitch and what pitch means. So we already know the word decibel, and decibel is how loud or how soft something is. So we could compare a decibel to a vacuum over the decibel level of a whisper. Now, I will say that you might hear some higher decibels throughout this video because I know for a fact that my neighbors are outside working. So sometimes you might hear their radio, which has some high decibels. You might hear their dog barking, which has some high decibel noise. Or you can even hear them talking. So I'm inside my house. We hopefully won't hear too much. But if you hear a dog barking, it's not Letty. It's actually their dog. Their driveway is basically right outside my window. So think about those decibels versus the decibel level I have. They can't hear me because my voice is quieter. All right. So decibel is how loud or how soft something is. But today we're going to talk about pitch. So don't confuse the two. Pitch basically is how high or how low a sound is. So even if it's the same, it's my voice, I could change the pitch to be very high like Mickey Mouse, or I could change the pitch to be very low like, I don't know, maybe Cookie Monster. He has a low-pitched voice. All right. We also can think of musical instruments. They can make different pitches too. For example, my piano. We have, that's a low pitch, very low sounds. On this end, we have some high pitch sounds. Most musical instruments are going to make different pitch sounds. If I had a xylophone, you might actually have that around your house. It's a colorful instrument where it has different bars of different lengths. I know the one that I had as a kid had a red bar that was really tiny, and then it was all the colors of the rainbow, and the bars grew a little longer each time. And then we got to the last bar, which was purple, and that was the biggest bar. And if you hit it with a mallet, which is like a stick to hit the xylophone, the shortest bar actually had the highest pitch, and the blue bar had the lowest pitch. So that's what we have with the xylophone, and the different bars make different pitches. Just like over here, although it's not colorful, the keys are either black or white, but different keys make different sounds, so different pitches. Now, the shortest bar on my xylophone would have the highest pitch, and the longest bar would have the lowest pitch. You can also compare it to a guitar or a piano. I don't have a guitar, but I made a homemade one, which is just a box with some elastics. And what you would do is they still make pitch, and they could be loud or soft. And a guitar is a stringed instrument, and it makes noises when those strings vibrate. So I hope you can kind of see it vibrating in the camera. If I had slow motion, you could see really those sound waves, those vibrations. And as you can notice, some of my strings, this one's thinner and this one's thicker. And you can hear they're making different sounds too. The thickest string makes a lower pitched sound, and a thin string makes a higher pitched sound. I can also change the pitch by tightening the strings. So I'm going to push my finger down so the elastic is more tight. Now listen to this sound. versus when I don't. Hear the difference in sound? I also hear dogs barking. That's my dog in the background now, but their dog will bark. Oh, yep, now they're both going. Different pitches. I can tell by the pitch of my dog's voice which dog is mine. Letty has a higher pitched voice. Their dog next door is a little deeper pitch. You can also change the string length by pushing on it, and that will change the pitch. The shorter the string length, the higher the pitch. Okay, let me look at my book. You guys can open your science books to page 9 and follow along as I read the paragraphs out loud. So pitch is how loud or low a sound is. Musical instruments produces sounds with different pitch. With your highlighter, we're going to highlight what pitch is. So pitch is how high or low a sound is. Low pitch, high pitch. Now we're going to read about a xylophone. Paragraph 2, follow along. A xylophone has bars of different lengths that are tapped with a mallet. When a bar is tapped, it vibrates. Each bar produces a sound with different pitch. Shorter bars make higher pitch sounds than longer bars. So do any bars on a xylophone have the same pitch? Nope, they're all different. They're all different. They're all different lengths, just like the keys on my piano. They all make different sounds. They're different keys. Please highlight the last sentence of paragraph 2. Shorter bars make higher pitch sounds than longer bars. And now let's read about stringed instruments. Stringed instruments such as guitars and violins have strings that vibrate to produce sound. Each string produces a sound with a different pitch. A piano has strings too. Can't see it, but it's actually in here behind this. I have pictures in here, but this top opens up and you could look down and you could see all the little strings going on. A piano also has strings. The strings are of different lengths. The shorter strings on a piano produce sounds with high pitches than longer strings. So some examples of musical instruments would be guitar, piano, violin, cello. Our friend Erin probably can give us a lesson on this. Which strings on a piano make the higher pitch sounds? Think of those shorter ones. You could see the thinner string on my fake guitar. So highlight the last sentence, please. Shorter strings on a piano produce sounds with higher pitches than longer strings. All right, now we're on to paragraph 4. Shortening a string on an instrument can produce a high-pitched sound. You can shorten a part of a string that vibrates on a guitar by pressing your finger on the string. The shorter string will produce a sound with a higher pitch. So here's my guitar. And if I press down, you can hear that it's even shorter. It's even more higher pitched. Paragraph 5. Let's highlight in paragraph 4. The shorter string will produce a higher pitch. And then paragraph 5. Pitch also depends on the thickness of a string. A thin string on a guitar has a higher pitch than a thick string of the same length. Will a thinner or thicker string have a higher pitch? The thinner string. So let's highlight that last sentence. A thin string on a guitar has a higher pitch than a thick string of the same length. And now let's look at paragraph 6. The tightness of a string also affects the pitch. When a string on a guitar is stretched tighter, the pitch becomes higher. So how does the tightness of the string affect the pitch? The tighter the string, the higher the pitch. So let's highlight that last sentence. When a string on a guitar is stretched tighter, the pitch becomes higher. All right, so think about what we just learned, summarize it in your head for a moment. And in our next lesson, you're going to need some boxes and some rubber bands because we are going to be conducting our own experiment. So unfortunately, the instruments we have created are left in our classroom lockers. So I hope you guys over the night, over the afternoon, whenever you're watching it, can find a box and some rubber bands because tomorrow we're going to use them for some instruments. Alrighty.